My name is Christina Pullig-Gomez, and I'm here with my team today to talk about the textile industry pollution of microplastics. First of all, what are microplastics? Well, just like the name sounds, they are tiny particles of synthetic polymers. They must be between 1 and 5 millimeters in size, and there are 5 types delineated by their shapes. Today we'll be focusing specifically on fibers, which are long filaments shed from synthetic textiles. We chose to focus on the textile industry because microfibers are the most ubiquitous form of microplastic pollutants. This is due in large part to the fast fashion industry, which creates garments that are created to be cheap and rapidly replaced. These garments are usually made of synthetic materials and manufactured using unsustainable techniques, which causes more microfiber shedding throughout every phase of the garment's life cycle. To talk more about that and the environmental impacts of microplastic pollution, I'm passing it along to Gabrielle Cassell.
It isn't simply the production of synthetic clothing that leads to microfiber pollution, it's every phase of the life synthetic clothing garment. These 4 factors are the main contributors to the present microfiber pollution issues that we observe today. So during the production phase, there are certain techniques utilized that have been shown to lead to the release of more microfibers during a product's lifetime. Examples include the loose weaving or knitting of fabrics with short filaments and cutting fabrics with scissors versus using thermal cutting techniques. Throughout the use phase, it has the tendency to release fuzz both when being worn and when being washed and dried in home machines. Although the effluent treated by wastewater treatment plants meet water pollution emission standards, it still contains significant amounts of microfibers. In terms of improper disposal, both pre-consumer and post-consumer clothing is often discarded along with other common waste instead of making reparations for minor damage or donating clothing that is no longer used. A lot of these clothings are either sent to landfills or incineration facilities where they will either contribute to ecosystem contamination through runoff or, if incinerated, toxic air pollution. So it has led to the contamination of both terrestrial and aquatic biomes given their chemical and synthetic nature. Many animals that form the basis of aquatic food chains, such as zooplankton and fish, often mistake microfibers for food and consume them, which has allowed microfibers to enter both aquatic and terrestrial food chains. This contamination has also been spread to humans. And this consumption has been shown to lead to multiple health problems such as the disruption of the endocrine system, liver toxicity, reproductive issues, digestive issues, and bioaccumulation of toxic chemicals. To continue on to the system description is Coddie samples.
There are 2 ways to describe the system of microfiber pollution in the environment. The DPSIR model demonstrated here breaks out parts of the system into drivers, pressures, state impacts, and responses. Key drivers, such as human need and desire for textiles, feed into pressures such as unintentional or intentional release of microfibers into the environment. The resulting state is a buildup of microfibers in both aquatic and terrestrial biomes, ultimately impacting the food chain as well as animal and human health. Responses such as ethical and sustainable clothing production can link to any part of the cycle and create an overall more sustainable system. The Meadows system model demonstrated here evaluates the system in terms of source, sink, stock, flows, and feedback loops. In the system of microfiber pollution, crude oil is the main source, which creates a flow of textile production. This results in retailer inventory, which then creates a sales and disposal flow into the sink that is the environment. The main feedback loops of this model are consumer demand, which is a reinforcing feedback loop, the non-renewable resource, which is a limiting feedback loop, and environmental capacity for pollution, which is a balancing feedback loop. In this system, the reinforcing feedback loop is currently outweighing the balancing feedback loop, and an unsustainable system has resulted. Next, we'll be moving on to sustainability analysis with Parissa.
I'll be talking about environmental, economic, and social sustainability in this system. Environmentally, we see widespread pollution, GHG emissions that are being released from textile factories, and textiles that are typically petroleum-based polymers. This is also, as Gabrielle said, disrupting the food chain. It can really cause some long-term health risks. Economically, fast fashion is the main source of microplastic pollution. It is inexpensive, quick to purchase, and easy to dispose of. Unfortunately, a lot of these workers see pretty low quality of life with very low wages and poor factory conditions at these factories. Also, people who are living in close proximity to factories are experiencing health issues and environmental hazards. Socially, we see tourism contributing to increased plastic waste, especially in coastal regions. Marine litter increases 40% during peak season of travel, and most plastic waste does consist of synthetic microfibers found in textiles. When it comes to fast fashion, we tend to have throwaway culture rather than a culture centered around thrifting or buying used. Moving on to recommendations and conclusions, we've got Brigitte.
Through our research, we have found many recommendations that can be made in order to make the system sustainable. On a corporate level, there can be changes in terms of production of textiles. It is estimated that combining synthetic fibers with natural textiles can reduce fiber loss by up to 80%. Another solution is changing the textile properties, such as how the clothing is knitted. Wastewater treatment plants can be updated to include new technologies to prove more effective to reduce microfiber pollution through improving textile fabrics rather than the costly changes to wastewater treatment plants. Changing textiles will change the entire system structure, which is high on Meadow's list of leveraging systems. On an individual level, consumers can invest in prevention techniques such as laundry balls and filtration systems for their washers and dryers. Just improving one's washing methods, we can cut the release of microfibers by an estimated 70%.
Thank you so much for joining us on our presentation about the textile industry's pollution of microfibers. As we can see, this is a huge challenge, but we can overcome our microplastic contamination and make the world a better place. Thanks so much.